In this video, we're talking about how to graph a parabola. And remember that a parabola is a U-shaped graph that looks like this or like this. It can also open to the right or open to the left, but we'll talk about that later. If a parabola opens up like this one, that means that its vertex is its minimum point, as at the bottom here, and the parabola opens up. That means it's going to have a positive x squared term. If the vertex is a maximum at the top and the parabola opens down like this, that means that the x squared term is going to be negative. If you want to graph a parabola, of course, as with any other type of graph, you can always just plug in points for x and find the corresponding points for y, and then plot those points on an xy coordinate plane. So for example, we could plug in x equals 0 and find the corresponding point for y, and then we'd plot that along the y-axis, find the value for y when x equals 1, and then come over here to about x equals 1 and plot whatever point was associated for y, and we could just continue plotting points until we got a good picture of the graph. But I'm going to show you a more efficient way to do it now, which is to look at the equation we've been given, in this case y equals x squared minus 8x plus 13. First of all, we notice that the x squared term is positive, so we know that the parabola is going to open up. It's going to look like this, and its vertex is going to be the minimum point. Then the next thing we want to do is figure out where the parabola intersects the y-axis, and the way that we'll do that is by setting x equal to 0, because of course when x is equal to 0, we're here along the y-axis, so we'll find the y-intercept. So setting x equals 0, we get y equals 0 squared minus 8 times 0 plus 13. We get 0 here and 0 here, so we get y is equal to 13. So we can graph this as 0 and then 13, which will be about right here. So that's our y-intercept. And now we want to find our vertex and the axis of symmetry. So the axis of symmetry is going to be the line about which the parabola is symmetric. And it's going to go through the vertex right through the middle of the parabola. And you can almost think about it as if you folded this parabola over on itself along this line here, this half of the parabola on the right side of the axis of symmetry would lay right on top of this half of the parabola on the left-hand side of the axis of symmetry. So the way that we're going to figure out where the vertex is and where the axis of symmetry is, so we're going to complete the square of our original equation here. Remember, when we complete the square, we want to take the coefficient in front of our first degree x term. In this case, the coefficient is -8. We always have to remember to include that negative sign if there is one. And we're going to take -8 and we're going to divide it by 2. We're going to get -4. Then we're going to square whatever we get as the result. -4 squared is going to be 16. And then 16 is what we want to add to both sides in order to complete the square. So we'll get y plus 16 is equal to x squared minus 8x, here's where we add in our 16, and then we have a plus 13 that we keep here on the outside. We get y plus 16 is equal to, and here our x squared minus 8x plus 16, now that we completed the square, we know this will be a perfect square, and we can see that it's quantity x minus 4 squared, and then plus 13. We'll subtract 16 from both sides to solve for y, and we'll get y is equal to quantity x minus 4 squared minus 3. Now with the equation in this form, we can easily pull out our vertex. The vertex of the parabola, we're going to get the y-coordinate for the vertex from right here. It's going to be -3. So we're going to count down from the origin, 1, 2, 3. So it's going to be right about here. We can go ahead and draw a dashed line. This is going to be y equals -3 right here. Then the x-coordinate from the vertex we're going to get from right here. It's going to be +4. So we're going to go out to about +4 right here, and this is going to be our axis of symmetry, which means the vertex is going to be this point where they meet right here. So our vertex is at the point 4, -3, which we've graphed right here. We already know that the parabola intersects the y-axis at this point here, 13. So what we can do now is go ahead and connect the y-intercept to the vertex like this. And then remember, we know that the parabola is symmetric about this axis of symmetry. So what we can say is that we went over 1, 2, 3, 4 to get to the vertex and the axis of symmetry from the y-axis. So we have to go over 4 more, 1, 2, 3, 4, and we'll have then this point here, 8, 13, which is right about here. And remember, the distance between this point, the y-intercept, and the axis of symmetry should be the same as the distance between the axis of symmetry and this point on the other side. That's what we're trying to obtain there. And then we go ahead and connect this point to our vertex and try to make the parabola look as similar on the right-hand side as we can to the left-hand side we already drew. So that's how you can use completing the square and the y-intercept and this axis of symmetry here to graph the parabola instead of just plugging in points.